If 1/2 x plus 1/3 y equals 4, what is the value of 3x plus 2y? You might look at this and say, well, how am I supposed to get an x and then a y and then add them? Well, in theory, if you plugged in an x and a y, that worked. So if you plugged in, I don't know, I'm making this up, x equals 2 and y equals 9, and then you plug that in here, you would get an answer that works. So that's actually not too bad. But we can also solve this algebraically by transforming this side, this 1/2 x plus 1/3 y, directly into 3x plus 2y. And then we're going to get the answer directly. So notice, in order to make this x look like 3x, right, 1/2 x to 3x, what do I have to do? Well, I've got to multiply it by 6, because 6 times 1/2 is 3. Similarly, if I want to get 1/3 y to look like 2y, I multiply it by 6, because 6 times 1/3 is 2. So let's multiply both sides of this equation by 6. So I get 3x plus 2y, which is exactly what I wanted. And then 4 times 6 is 24. And there we go. So the answer to this question is 24. You can just solve for it directly. This is an old style SAT question for algebra where you're given this, only one equation. You want to find the value of some other expression. It's not immediately obvious how you might solve for x and y, and that's what a lot of students might do. But they'll quickly find that they can't solve for an individual x and individual y. But what you can do instead, as we saw, is transform the original into what we're looking for directly. As I said, you could also mess around and find an x and a y that, when you plug them in here, give you 4. And then you plug those x and y's into this, and it will work, but that's a lot of work. If you can do that, you should be able to do this method, which I think is more direct and less prone to making arithmetic errors. So like I said, standard old SAT style question. So it looks like they will be preserving some of the old spirit of some of the old math questions on the original SAT.